it later.
Sure. Hi, Marcy. Can you hear us okay?
Yes, loud and clear.
Okay. Kendall, maybe we can also give Marcy a presenter right when he's going to speak. And let's see.
Hello, Katar. Hello, Phil.
Hello.
Morning.
Hello, Kader. This is Subha. The other day I was looped in.
Yeah, Tekem, right? Yeah. Hi.
Yes. Yeah.
Nice to have you here.
Thank you. Yeah.
Think up later this week.
Sure. This is my first call. Sorry.
So.
Yeah. Nice to know you all. I know Shubham very well. He's been helping us.
Okay. Yeah.
Hi, Kader.
Hi, Suresh. Good morning. Good evening.
Yeah, good morning.
Hi, good morning, Kader and Suresh.
Good morning.
Hey, Daljit. Hi, Phil. Good morning.
How are you?
Yeah, very good, Phil.
Hi, good morning, Phil.
Hey, good day.
Couple of more minutes, then we'll start. I still don't see Nets. Nets, are you there?
Yeah, Nitz joined, I think, just now.
I'm here, Kader.
Hey,
Hey, good morning.
Hey, good morning, Nitz.
Happy to be here.
Thank you very much. Hey, Javier, Justin. Thanks for joining.
Hi. That's you.
Well, you can see my screen, right? Just
Yes,
okay.
looks great, except that picture in the middle.
That's the best part of this slide. It kind of hides all the unwanted things behind and sparks in front.
You look great, Phil.
Yeah.
Kendall, only you know what my real picture looks like.
That one you sent me that one time was hilarious.
I also know, Phil, you sent me to, remember? It was like for a minute, what's going on? I thought maybe Phil doesn't want to, join me in this presentation or something, right? I was getting started. I was like, okay.
So Kader, it looks like the joins have slowed down. Why don't we go ahead and kick this off? I want to take a quick minute and just welcome everyone to our monthly 5G focused Magma Ask Me Anything session. Cater's done a great job putting together a couple of speakers for us before we get to the Q&A. So I'll hand it off to Cater and let him take the ball.
Thank you very much, Phil. Good morning and welcome every one of you. Like Phil mentioned, Phil is from Magma Core Foundation, and I work for Wave Labs at a capacity of Senior Vice President, leading connectivity practice at Wave Labs. So moving on, let's kickstart the meeting for today. I just want to give a quick reminder, why are we having this meeting, right? There's three major objectives that we wanted to achieve out of this meeting. And this meeting happens every month, the second week Friday. So the first objective is we want to ensure community has a good understanding on ongoing and the future 5G development and testing activities that's happening within the community, right? So that's the first key objective. And the second key objective is we wanted to ensure we are able to enable the Magma community collaboration and alignment with other communities like Linux Foundation, networking, 5G super blueprint activities, and so on. That is the second key objective. And finally, the third key objective, why we are here today, is to learn, share, and support each other to grow the community and grow along with it. And why are we doing all this is mainly because 5G is a great opportunity for every one of us here. And collaboration is the only way, so we are able to together increase the adoption of Magma for 5G in the community as we continue to evolve Magma 5G on the Magma code base. Today's agenda, welcoming myself and Phil pretty much covered it, and then we will have a quick R&D update, both from the development and testing point of view from Suresh and Parthiban. Then we will have Macias Mazur. Most of you know him. For those who do not know him, he leads the telco efforts as product strategy manager at Canonical. He would be sharing with us Ubuntu for Magma by Canonical and what kind of contribution Canonical is making towards the adoption and evolution of Magma. Then we will have Nityananda Jagannathan, but we call him with love Nits. Nits, thanks for joining.
Yes.
The senior product manager from AWS. And in fact, I like his quote in his LinkedIn, living on the rugged edge of computing. And especially Magma is designed for edge, and it kind of aligns together. So looking forward to hear more from you, Nets. And then we'll have a closing, Phil and myself. With that, probably we'll end the year's last meeting, Magma 5G meeting, and we will resume our meeting next year. So with that, let me first hand over to Suresh to give us a quick update on the development status of Magma for 5G. Suresh?
Yeah, thanks, Kader. For the community that are assembled here, just want to give a quick update on Magma 5G SA. The features that are available now are UE registration and service through CPE, and then idle mode paging, and then basic 5G authentication. So these features were available for a while for the community to try out. In addition to that, usage reporting and charging also is now ready. So that also can be tried by the community. And the features that are in development today are IPv6 support and dynamic policy support and 5G QoS. As such, 5G QoS has finished its merge onto the master. However, there is one bug causing little difficulty, causing consistency loss. So plan is to fix the bug on 5G QoS sometime this month itself. So then we declare availability of 5G QoS as well to the community use. And another big feature we are developing as part of Q4 2021 is stateless support. Basically, on Magma project, our goal is to make 5G core to be on par with 4G in terms of feature parity. So that's the reason we took stateless feature on the access side. And all the state information today on Magma 5G SA is in the maps. And now the plan is to transition all these states into Redis DB. That exercise is going on. And the feature will be available in Q1 2022. In parallel, hardening of Magma 5GSA is in progress, and scale test for 200 UEs in mixed mode is going on now. When I say mixed mode, it is 10% of invalid UEs and 90% valid UEs. So that hardening exercise is going on. And in addition to that, as part of code quality, we are stepping up the unit test coverage. Most of the modules have crossed 60% unit test coverage. And the last module that is falling short of 60% unit test coverage is NGAP. Our goal is to make NGAP code also cross 60% unit test coverage before end of this quarter. So that's the development update on the Magma 5GSA project. With that, I pass on the baton to Parthiban to give test update. Over to you, Parthiban.
Yeah, thank you, Suresh. Hello, everyone. Yeah, so we have different test tools in engagement for us to make the Magma really hardened and make sure the community has a good 5GSA core available. So we are using right now the TerraVM, UERAN simulator, and ABOT for all of the integration testing. All the features which are being discussed by Suresh in the previous slide, it's are very much available. We do continue to harden it. We are running a lot of regressions as well to make sure all the new feature developments doesn't break any of the existing features. That's one of the main goal over there. And Suresh gave a little preview on scale test, what's going on. We are using Spirent to make sure the code is able to scale enough. And he talked about the mixed mode already, the 10% with invalid and 90% valid. And the target for us for this quarter is to make sure we are able to reach the 200 UE with 4 sessions per UE, where we have 4 policies in each UE as well. And we are able to make a 5 UE per second attach rate. And this is what we are targeting with the 400 Mbps aggregate throughput, both for the uplink and downlink. And all this we are trying to make it in the Magma hardware infrastructure. What we are trying to do is with the 4 core and a 4 GB RAM machine. So it should be pretty much a small box, hand size of a box, which can be shipped anywhere. That's the scale we are trying to do it now. On the SIT, the physical equipment testing, right now the target is to make it with the Bisel GNB and Huawei UEs over there. Right now, somewhere or other, the Bisel's GNB are dropping the packets silently, where we are not able to find out why packets are getting fallen. The Magma core right now is completely 3GPP compliant. We are compliant on terms of supporting all of the mandatory IEs plus that of the conditional optional IEs. And seems to be some optional IEs are being making this cause. We are in the analysis. We are yet to close on this one. That's the update on the real physical equipment testing. And another update I have from the test side is we are in the Magma community. We have put up a central CI/CD dashboard, which actually gives leverage for the community members to come in and do any kind of testing and upload that to the community members. So one such is this, and from the Wave Labs, they are able to put it up a test tool, the ABOT, and they are able to test the Magma community code, the 5G core, and the results are getting uploaded directly here. And with this opportunity, I welcome the members to join this one. You could also be part of this. You can also start testing the Magma 5G core for your POC and other areas, whatever you are doing efforts, and we could be able to upload that results as well into the CI/CD dashboard. So yeah, this is pretty much from the test side. Yeah, thank you, Kader. Over back to you.
Yeah, thank you, Parthiban and Suresh, for the good update on development and testing side. And I just wanted to share that the whole community is putting their head down to make sure that the 5G SA core has a working with real equipments, as well as working with the high performance and scalability that we expect it to happen, so we can go and start trailing and deploying in some of the places. And there's a lot of work is ongoing, good work is ongoing. Appreciate everyone to join together and make this happen moving forward. Like Suresh and Parthiban mentioned, there is a dedicated channel available. If any questions or any clarifications that you need with respect to the Magma deployment configuration, please feel free to reach out in that dedicated channel in Magma Slack. And also there is a free orchestrator that is available. There's a number of community members are already using it to deploy their 5G code from the GitHub and connect to this orchestrator and trailing it out. So I also encourage if you wanted to do the same thing, please reach out in the channel. We'll be happy to set that up. And with that, let's move forward to our next agenda in our for our call today. I would like to privileged to invite Macias to share his contribution towards Magma community by Canonical. Macias.
Okay, thank you very much for that kind introduction. So
hello, Masi, can you hear us?
I think I'm mute.
okay, can you hear me now?
Yeah, we can hear you. You're back.
Sorry for that. Yeah, so basically I'll be talking today with my colleague, Guillaume Bellinger, who is working also on the Magma project with us. And well, basically, I'm not sure if I have to, but I will introduce Ubuntu. Ubuntu is one of the Linux operating systems, the popular one in terms of hosting telco workloads. And in general, basically, we are doing a lot of stuff in telco, starting from our work with public clouds and like the distribution that is optimized there. We are working on the core network and on the Mac use cases with non-telco type of people. So basically what we are focused on is the speed of innovation and enabling the fast deployment and operations of any type of open source software which is used in the ecosystem, just like Magma is. And working on the user equipment side with Ubuntu Core, which is like a Ubuntu distribution dedicated for robotics, drones, and this kind of stuff. We're working also a lot on Open Run with our hardware partners, basically on real-time kernel and acceleration of these types of workloads on the EPC front and on the core cloud with our Kubernetes and OpenStack automation that is there. So that's more or less what Canonical is. And besides Ubuntu, what do we do? The team that you might have seen lurking around on the Slack channels and asking questions and doing stuff is Javier, Bartek, Guillaume, and me. And obviously it can also be you because we are hiring for that kind of roles. What we are focused on and what our contribution to Magma is infrastructure automation. And that's what we are looking for to be doing. So as you know, the like standard configuration management tools like Chef, Puppet, Ansible, and such were created. They are very good and they are useful for what they were created for. Later on, more popularity, especially with containerization, came with declarative deployment and things like Helm. And we moved with Kubernetes to more operators-driven kind of stuff. So basically, what we are doing is taking this concept a little bit forward with a tool called Juju and basically charmed operators. And this is one of the first things that we want to use to make life easier for Magma community and all of you developers and users. So operators are Python software packages, and they are doing lifecycle management, but also like day-to operations, actions, and integrations. And what is our goal basically is that with a single way and single method of deployment, we are able to deploy Magma on all of the public clouds, on bare metal machines, on VMware clusters, Kubernetes, and OpenStack in the same concise and easy manner. And that's basically the main goal behind what we are doing. And we are doing this because Magma is very important for us in general. We care about open source mobile networks, both in the private mobile network space, but also in bigger deployments as mobile network operators. So basically, as you have seen, this type of projects that are there, like Linux operating system, Kubernetes, the OpenStack, and so on, we are focused on the infrastructure part. And if we look at the infrastructure components that are there, which are important for us, is MAS for bare metal automation. So basically, when we install Access Gateway, we'll be installing it on different types of hardware, and MAS is making sure that the automation on the hardware bootstrapping level happens. The other parts of the project, like Orchestrator and Federation Gateway, are Kubernetes based. So basically you can use, for example, microcades for that. Besides Magma, we are also contributing to OpenRun and Etsy OSM. These are the two main open source projects in Telco where we have heavy presence. In Etsy OSM, I'm also leading the VNF onboarding task force, so obviously Magma will be very nicely integrated and be able to be onboarded. We even some time ago did a joint Magma community and OSM community hackfest around onboarding Magma, and we want to continue those type of efforts to basically be able to build entire end-to-end open source mobile networks ecosystem. And with that, I will give voice to Guillaume. I'm not sure if you can unmute yourself, but basically I wanted you to tell a little bit of what we are doing in details technically. Guillaume, are you here?
Yep.
Yeah.
You hear me?
Yep, we can hear
Loud
you.
and clear.
Awesome. Perfect. All right. Thank you, Maciek. Okay, so I'll go through what we've been doing up to now with Charming Magma and what's coming up in the next couple of months as well. So as you know, Magma is made out of three main components. We've got Orchestrator, Access Gateway, and Federation Gateway. So we're going to charm each and every one of them, but the story will be a bit different for each of them. So we started with Orchestrator. Orchestrator is a Kubernetes, well, right now it's deployed on Kubernetes on AWS. So if you follow the official documentation, that's what is going to happen. So what we've done is for each of the Orchestrator service, so there's like 20 or 30 of them, we created charms. And we also are in the process of creating a bundle so that you could simply deploy Orchestrator with one command on your Kubernetes cluster. So that's what we're working on right now. Next is going to be Access Gateway. So as of today, if you want to install Access Gateway, you've got to like wget a script, and you're going to install it on your Ubuntu machine. So there's two things we want to do here. First of all, we're going to want to create a snap of Access Gateway. So on Ubuntu, you could simply do a snap install of Access Gateway. And we're also going to build a machine charm, like Maciek mentioned earlier, to deploy Access Gateway on your machine. It's going to be integrated nicely with MAS. And then once we're done with that, up to Federation Gateway, here the story will be similar with as Orchestrator, since it's a Kubernetes service. All right, so the goal here is to have a very, very simple user experience with deploying Magma. So if you're already on a Ubuntu machine, you have a Kubernetes cluster, you have Juju installed, all you have to do is Juju deploy Magma Orchestrator if you want to deploy your Orchestrator. So that's the story. That's the goal. That's what we're aiming towards, and we're very close to have that working. And your other operations are going to be very simple with Juju command as well. So if you want to scale up, if you want to upgrade, somebody's having trouble. So if you want to upgrade, if you want to do any type of operations, the story is going to be as simple as that as well. So there's that for this slide.
Yeah, just a super short comment. Obviously, Guillaume is saying all the time about Ubuntu, but actually Juju is working on any Linux operating system. So we would be happy if you use Ubuntu, but you don't have to.
Yeah, of course. Thank you. So now in terms, so at this point, we've been working on this. It's been mostly fully led by Canonical, but this is an open source project, and we'd very much love if the community wanted to get involved. On our side, we need to do a better job of displaying what we do. So we are going to get more and more involved in the project Charmed Magma Slack channel. We're going to post our PRs in it, saying, hey, that's what we've been doing. And if there are changes, if there's features that you would like to see in Charmed Magma, feel free to propose them. So contribution is very, very simple. All you have to do is create a new branch in the Charmed Magma project, create a PR, and we're going to review it. And that's as simple as that. There's a pipeline validating each and every change. And yeah, so I wanted to, at that point, I wanted to do a quick like just showing up what is our repo. But maybe Maciek, if you can skip to the slide where I have the references. So there you go. So our repo is located under Canonical / Charmed Magma. It's all public, so you'll be able to see it. Our charms, well, our bundle for Magma Orchestrator is located under Charm Hub / Magma Orchestrator. However, there's the warning, it doesn't work yet. So you can click on it, you can look at it, you can even try and deploy it. It's not going to work. But that's the current state of affairs. We'd be very much happy if you want to contribute, if you want to help, if you want to criticize, if you want to propose new features.
So, but actually, even just tell us what to do. I mean, you guys are in that for much longer time than we do. We are coming from telco backgrounds and we spent many years there. However, like Magma is also new to us. So if you see any kind of improvements or ideas how the installation could be easier or what kind of additional data operations should be happening, we are happy to help here.
Yep. And so, yeah, that's pretty much it for me. So we have a bit of time left. So if people have comments or questions or stuff like Maciek said that you want to see in those charms that you are tired of doing manually, let us know.
Yeah, one last thing that we also want to use this opportunity to announce the partnership that we do around Magma together with our Wavelabs colleagues. So basically, we will be working together in terms of us providing infrastructure support and Wavelabs providing any kind of Magma related stuff. So that basically we better integrate together. But now coming back to Guillaume's question, what would you like in those charms and what is needed? We're happy to take any comments on the chat or later on Slack channel.
Thank you so much, Guillaume, Massey. Any questions, if you may have, please post it in the chat. We'll take it towards the end of the session. Now I would like to call Nitz to share his view and his contribution towards the Magma community from AWS. Let's float you.
Let me share the screen. Give me 1 second. Sorry, we don't use Zoom as much, so I'm trying to figure out how to get the presentation mode going.
At the bottom, you have controls, participant, chart, screen share screen. I mean, you don't see those?
Other sharing. I understand what the problem is. So we are prohibited from, with the new update of Mac, there were some changes to the.
Have you changed your presentation? If you want, I can for you.
It is just the Mac OS essentially like pushed me to change the permissions. Now I should be able to say it. There you go. Okay. Let me know if you can actually.
Yes, can see your screen. Let's please go ahead.
Awesome. First of all, thanks a lot for having me in this Magma forum, and like it's been an honor to come here. And we started engaging with Facebook and Magma Foundation probably about a year ago, and we have made significant progress since then. And we'd love to share the progress we have made, where we are today, and what options the community has with respect to AWS, and especially when you want to deploy private mobile networks using our solutions. So today I'm going to be mainly talking about the range of AWS options that you have with respect to Magma, and also some of the implementation that we have done by working with Facebook and the Magma Foundation, and that we currently publish a blog, and the Army is published in the marketplace, and you are welcome to try it out. And we are always open for feedback and where we can improve the solution as well. Right. Before we dive into the specifics, I wanted to kind of touch upon, where our customers are coming from, and with respect to Magma, and also like, where we are seeing the most traction, right? AWS is a customer obsessed company. Always we listen to our customers, what they want to do, and build solutions accordingly. So as you can see, there are three broader use cases, right? We have CSPs who are to build public network, and they wanted to experiment with Magma. While they have their own core or different options, they have like smaller enterprises or IoT, like sensor or smaller workloads. They wanted to try a smaller core, a local network, for instance, using Magma. And I think that's the first line of use cases. The second one where we have seen the most traction is really on the mobile private network side. And this is where, like, for instance, like a mining company wants to deploy a private mobile network using Magma, so that their mining operations can stay coordinated together, right? And we are also working with for the Rural Cloud Initiative for deploying Magma in the farmland, where you can track farm equipment, silo grain tracking, and things like that. And they want a low-cost solution and also like low overhead solution to manage at the rugged edge. So we are seeing the most traction from customers who want to build their own mobile private network. And Magma is resonating a lot with these customers, because the cost per bit to essentially like operate these networks is much cheaper compared with alternatives. And then, of course, there are also like fixed wireless access solutions, and these are seeing traction from in rural locations, for instance, like some locations in Brazil and like in developing countries, where the operators don't have a lot of background running, like communication networks, and they wanted to see how they can, get started using LTE instead of Wi-Fi with the fixed wireless access capabilities. This conversation is ongoing, and because it's a low-cost solution, the alternatives with AWS are a little bit on the higher end, and they have multiple other alternatives. But there is still potential here to continue to innovate and like engage with these customers. But for the most part, what the most traction we are seeing, AWS and Magma, is on the private mobile network side. We are working with a couple of partners, Bicells, and then a couple of, like GenXCom, so that like we can actually like deploy Magma solutions with AWS, the cloud and our edge solutions in the field. All right, so just from, before we go into like how we have implemented it, like, I need to kind of give a primer on the AWS set of solution space that you have from a Magma point of view, and then I can walk into some of the options for deploying them. So Dr. Werner Vogel, Amazon CTO in reInvent, he made a like a statement which resonates with me most, is that like AWS anywhere, right? Our goal is to have AWS start at the rugged edge, like from embedded devices and go all the way up to the cloud. And we have a range of offerings there, and all of them work together and like, able to solve customer use cases by coming, pulling together the data from the rugged edge, doing the analysis in the cloud, going back to the, to the edge so that the customers can take insights on a real-time basis. So from an edge computing continuum point of view, like you have, essentially we have like 3 RTOS devices, and we have Monitron sensors, and you have IoT Greengrass as a framework for aggregating all of the sensor data. And you have IoT Sitewise as a mechanism to, generate real-time insights at the edge without actually moving any of this data to the cloud. And then as you start moving higher up the workload, where you have more data being generated, you have digital twin. In reInvent of this year, we launched a twin maker, IoT twin maker, where you can actually like model real world for instance, like a boiler or something in a 3D, 3D, like I would say like a CAD diagram, and then you can add sensors and you can model it and look for predictions and predictive maintenance and things like that in the cloud. And you have RoboMaker. So all of these are gradually getting higher in terms of complexity and also the data generated. So as you start generating more data, you have to start moving some of these workloads to the cloud, and you would need higher end analysis in the cloud while you do some kind of processing in the local edge. And after we start moving towards like the rugged edge devices like Snowball Edge and Snowcone, we are starting to talk about workloads that require like compute intensive applications. For instance, you want to do video analytics, you want to run custom Kubernetes clusters, and like for your storage processing, anything you want to do, now we are starting to move the workloads that are running in your cloud to the rugged edge. And these are not necessarily going into your data centers. They can be on your ship, on your fleet. It could be in your farmland. It could be attached to a drone. So that kind of flexibility resonates a lot with customers. And then we recently launched, so Outpost was launched last year, but this year we launched Outpost 1U and 2U servers. And those are like high density, like small form factor devices that you can deploy into your on-premises data center for you to bring all of the cloud's goodness to your local premises, so that you can, where if your application is very latency sensitive, you can start taking advantage of the Outpost functionality. For at least for the sake of this particular talk, and then we have the cloud regions, local zones, and availability zones that provides always the flexibility that you need in terms of scale up, scale down. You have the most secure deployment and development environments, and you also have greater degree of manageability. As you start moving from the right to the left, you are almost always trading off something, right? In terms of amount of compute you have, amount of manageability you have, amount of networking capacity you have, load balancing, all of that, right? As you start going to the left-hand side, you have less flexibility. As you go to the cloud, you have the most flexibility. And Outpost is fairly right in the middle because it's starting to bring the cloud capabilities to your on-premises facility. So for sake of this particular conversation, keep note of Snowcone, Snowball Edge, Outpost, and Region, because they are Magma heavily placed. Our deployments actually are very centric to these particular solutions. So the edge to cloud architecture that I just talked to you, essentially for IoT devices, you have the core, Greengrass, free RTOS-based solutions, aggregating data, and they are moving them to either if you have an on-premises facility, either with Snow devices or Outpost, or if you have rugged environments where you have a Snowball Edge, doing some real-time number crunching for you, and you can choose which data needs to be sent to the cloud, and whether you need to send any data to the cloud or you want to operate completely disconnected from the cloud infrastructure. So you have a full flexibility with respect to what your application is, because connectivity is the foundational layer, but you want to add applications on top of it to really extract the full benefits of 4G and 5G. So this is where AWS architecture gives you a lot of flexibility in terms of what you want to do. You want to choose small compute, medium compute, larger compute, denser configurations. You have flexibility to choose all of them in your plan. So from a rugged edge point of view, I'm from the Snow Services side. I'm a product manager in the Snow Services team, where we're looking at Snowball Edge. It's a 50-pound rugged box. The mental model you think of it is it's a high-end desktop, almost getting to a 1U server capability. It's got 52 vCPUs and 7 terabytes of NVMe SSD and 30 terabytes of hard disk capability. And we have run, multiple 4G and 5G cores, not just Magma, on the Snowball Edge devices. And we are almost seeing like close to line speed with respect to the throughput on other cores. With Magma, the testing is ongoing at the moment. And then the other one is the snow cone. I was going to show you this, this is the snow cone device. It's roughly about the size of let's say a tissue box. It's got 4 vCPUs in total, 3 vCPUs usable, 8 terabytes of storage, or 14 terabytes of SSD. We have launched that, and it's roughly about 2 kgs or 4 pounds. And it is portable. It can go anywhere. And the good news for the sake of this particular audience is that it runs Magma core. And essentially this was the first engagement we started with Facebook Magma team. And we currently have it ported onto the Snowball Edge device as well as Snowcone. You can order one with the Marketplace Army, and you can actually test it out, the 4G solution on Snowcone. For the entire Snow offering, at this point, we are still on 4G stack. We haven't moved to the 5G yet, but we are starting to work with partners like Bicells to actually do some more analysis, build a full end-to-end solution so that we can deploy it to our customer sites. Okay, so just a little bit of I kind of walked you through what AWS solutions capabilities are there. I'm going to give you some examples of potential deployment models with Magma and AWS. So our AWS goal in general with respect to Magma is really we want to provide the tools, the components, the automated mechanisms so that we CSPs can accelerate development as well as quickly launching these products into the market space. So keep that in mind when you're going through these deployment approaches for the next 3-4 slides. So the Magma deployment model is pretty similar to what Canonical just showed, right? So we have a cloud strapper. It's like a bootstrapper for Magma that's running in the cloud. And that depending on the deployment, it actually spins up one or more orchestrators. And these orchestrators have a 1:n relationship with the access gateways. And the access gateways themselves could be anything. They could be running in the cloud, or they could be running on your on-premises on an Outpost, or they could be running at your forage site on a factory floor with a Snowball or Snowball Edge. So you have a range of capabilities that you can select from. So what you're seeing here is how will you deploy a Magma solution with completely running in the region? So what will happen is that you have your own cloud strapper running on your own VPCs, and then you have an orchestrator running in a separate VPC, which is private subnet, and you give only secure access so that your data and your control planes are separated. And you could run the access gateway. You can spin up one or more access gateway solutions in the region itself. It could, when they say region, it could be an availability zone, it could be a local zone. It depends on your latency and your throughput needs. Because it's the entire stack is running in the cloud, it's suitable for applications which are not latency sensitive and they require low bandwidth. For instance, you could be thinking something like an IoT sensor. It's not sending frequent updates. You just need to monitor and send commands infrequently. You don't really need full edge deployment there. So you could start running this deployment in the cloud itself. And that also gives you the most flexibility to ramp up or ramp down your application profile. And this is the Snowcone deployment that we just talked about, right? So because this is a smaller form factor device, you could essentially have only one access gateway instance running on it at the same time. And we have direct network interface enabled on this. So, and you can configure multiple VLANs. So using the same, single Ethernet port, you could potentially configure 2 VLANs one for one for talking to your ENB, and your other for like managing control plane, or your for your backhaul, right? So you could do either one of those. And essentially, like access gateway can be spun up, multiple access gateways can be spun up from your orchestrator. Like if you want to deploy, let's say, a snow cone across your farm, 50 snow cones, one orchestrator, you can still do that, right? And we're going through that kind of an evaluation at the moment. How many snow cones can you actually connect to a single orchestrator? And that kind of prototyping is ongoing. And then the last one that I want to touch upon is the Snowball Edge. Given that Snowball Edge has a lot more compute capability, you can start to imagine a solution where, like, some access gateway elements can actually, like, not just a single instance, you can run multiple instances of it. Or potentially, we are even talking about, like, what will it take to run an orchestrator directly onto the Snowball Edge in a solution where, if your control plane today is in the cloud and your data plane is on the device for rugged edge. Now, if you want to be in a fully disconnected solution, what will it take to move some of the control plane elements to the Snowball Edge device? Because it's got 52 vCPUs, there is a lot of the compute capability that you can leverage. And so there is an ongoing approach to figure out, can we start moving some of the cloud workloads to the edge and have a single Snowball Edge and satellite or snow cones to meet the customer's needs, and it will be much cheaper and more flexible to increase or decrease based on the demand. And just to be clear, like, the snow devices are a leased model. So essentially, like, the devices are owned by AWS, and so it's, from a customer point of view, it's mainly from a operational expense rather than a capital expense. So if you want to add like 2 more snow cone into your edge deployment, you can just add her for as long as you want, and you can always like send them back to AWS. So that level of flexibility, along with your ability to scale up or scale down your solution, will become crucial as 5G becomes more prevalent. You feel, let's say, like, all of a sudden you expect more UEs to come into your network, you just add another snow device, and as soon as you want to scale it down, you can always send it back. That's for the deployment model. I think this is just a little bit under the cover with respect to all the work that we have done on the AWS side to make it easier for customers to be able to order, right? So we work with Magma to essentially to have a Magma instance on the marketplace. So customers now have an automated way to take the Magma instance, choose which kind of a device they want to go to, whether you want to push it on an Outpost, whether you want to push it on a snow device, with a snow cone, Snowball Edge, and you can deploy it, and specify an address where it needs to be shipped, and the devices will basically go there with your Magma access gateways, like software already, like enabled on it, and then you will have the ability to like orchestrate with your cloud strapper and with your orchestrator, and you should be able to manage these devices out of the box. While we are not there yet, our goal is really to get to like a zero-touch mobile network where you basically click a couple of buttons, push the access gateway solution onto any of the snow devices or even Outpost, specify an address, and we ship it there. And our deployment speed, we want to get to from like months to potentially like a week or even like days. Right, so that is our main intent with respect to our collaboration with Magma. We want to make it so easy for the customers to build private mobile network with AWS. And also, like, given that we have a full range of flexibility from the low end to all the way to like higher dense compute with Outpost, you have the flexibility depending on your application. Like if your application, for instance, like we have worked with customers who want to deploy private mobile network to do social distancing, monitoring, or like video analytics, or telehealth, for instance. So those edge application enabling by building on top of Magma connectivity is what is the most interesting piece for AWS. We wanna see where you build and innovate on top of our foundational like development architecture. I mean, you can always learn more about what we were doing here. We published a blog recently. I posted a link on the presentation. You can go look at the details of what we have done with respect to the Magma and AWS collaboration. And it's an ongoing, improvement. So we are continuing to develop, continuing to work with Facebook and the Magma community. So feedback is always welcome. You can always reach out to me on LinkedIn, and would love to work with you. Anything that's missing, you want to see more collaboration, would love to partner and learn more as we go through this iteration. Okay, that's all I had. If you have any Q&As, I can stay around.
Thanks very much, Nitz. We do have about 12 minutes left on our time today, and we would love the opportunity to open things up for Q&A. I think Suresh and Parthiban and the other development team are still on the call. We also have Maciej and the folks from Canonical and Nitz available to take questions. So Kader, if you want to take the Q&A session and moderate any questions that come in from the team, and I'll monitor anyone who wants to ask their question on the chat if they're less comfortable unmuting and coming live on the Zoom call. So with that, Kader.
Thank you, Phil. I think I have a question for Canonical team. Could you please elaborate a little bit more on Mars, right? That you mentioned a little bit on bare metal. How does it relate to installing Magma A gateway in the bare metal? That's the question.
Yeah, sure. So Mars is the open source metal as a service project, and its main goal is to be able to bootstrap and install any OS on any type of hardware. So Mars is supporting stuff from Dell, HP, Lenovo, many different manufacturers. And after you press power, it takes care of installing the OS, but also configuring all the network connectivity, storage, and then enabling a Kubernetes layer on top of it so that you can actually install stuff. So basically in Magma context, whenever you want to build up an access gateway from scratch, you obviously would need that hardware to become operational, have everything configured, have the OS installed and so on, before you start installing any type of Magma workload on top of it, right? So that's the main role for Mars, and Mars also allows you to manage the entire fleet of such devices. So basically it means that if you have either a huge data center or several thousands of edge sites running Mars will take care of the management and configuration of the entire estate, not only a single instance of the access gateway.
Thank you, Maciej. Next, this is for you. In your summary slide, you kind of mentioned that Magma solution reduces cost per bit delivered on the mobile network, and also reduces to deploy the mobile private network from 6 months to weeks. Is there any live examples, use cases that you can share on this context?
So the deployments, right now we have not reached a production deployment yet, Kader. So I don't have the data to share right now, but at volume, so there are two components to this, right? So I said almost always from production deployment standpoint of view, you need a third partner who's going to be the one who's going to be operating the network. While we are working with, for instance, Bicells or GenXCom to finalize this queue that will go into a specific solution. And at scale, we are looking at, what data we can massage to actually make operational cost of running AWS related cost low for the customers. And we did some comparison with respect to an alternate solution that they can go, customers can go deploy themselves. Essentially, the total cost of ownership of running that solution is it did come out cheaper with the AWS option, but we don't have a final number yet because we haven't deployed it in actual production at volume, right? I think those kind of analysis is coming as we start ready to get deployed in the production environment. We will actually be able to share some more of those details. But the operational cost, so the reason why I was mentioning cost per bit is low is because like you are not actually like, it's an OpEx versus a CapEx. You're not purchasing this equipment. These are leased equipment, which you have the flexibility to increase or decrease. So that's where the cost reduces overall. And given that like the marketplace army is free and everything is completely packaged, the amount of upfront cost you have to put forward to get a solution at your site is pretty low. So that's what I meant by that.
Thanks, thanks, Ned. This question is for Canonical team. In one of your slides, you mentioned open source Nano. Have you tried Magma installing into that open source Nano and have it orchestrated? Is there any work done on that context?
Yeah, so basically there was a Hackfest, which is like a community event handled last year around that one, and the older version of Magma was onboarded with OSM, and that stuff was created. And currently we will be working on the new release of Magma to also be integrated with OSM and have the whole onboarding tested. But I think that we can reuse a lot of work that was done during the Hackfest and basically just upgrade the versions and everything and change the configuration a little bit, and it should work fine. I can send some on the Slack some pointers to this like previous work being done in packages if someone wants to try it out.
Thanks, Nancy. Phil, any other questions?
No, I don't have anything coming in from the chat. So we still have 6 minutes of time. If anyone on the bridge wants to raise any questions, this is really intended as an Ask Me Anything session. So even broader topics, we'll try to get them fielded as best we can. I see Thomas on the chat asks a generic question. Does X2 handover and S1 flex for intra access gateway supported by Magma in the latest version? And Thomas, I believe the answer, well, this is a 4G related question. Because we haven't tested the handoff capabilities in 5G quite yet. X2 handover is certainly supported in the current release, the 1.6.x releases of Magma. S1 Flex was introduced in 1.6, but I'm going to have to check with others to confirm its status. And again, those are both for handoffs within a single access gateway scope. Inter-access gateway handoff is still being worked. One more call, 4 questions from the bridge. Live questions if you want to unmute or in the chat.
There is one question asking about this is coming from Sampreet, and he's asking, can we run Magma on the ARM processor like Raspberry Pi? Phil.
Oh, I'm sorry, that was very early. Yeah, there is activity on ARM ports for Magma. As you may know, ARM is a premier level partner of the Magma Core Foundation and has dedicated a small team of people to work on that. And there have been successful deployments of Magma that have been announced on the chat ported to small scale ARM devices like Raspberry Pi, which are lab exercises, obviously, because I don't think a production core running on a Pi is too practical. But if you look in the Slack, there is a very active team working on ARM ports, and you can find more information on the Magma ARM Slack channel. Shubham, if you're still on the chat, could you confirm the exact name of that channel and drop it in the chat for us? Thank you.
Yeah, it's Project ARM support.
Okay, easy enough. Project ARM support on the Magma Slack, and you should be able to find more information about that.
I wanted to add a little bit there. Like, so to be clear, the snow cone is a four core product, right? But Magma is running on a 2-core Intel Atom, like deployment. So I can see why not, like where you can move it to a Raspberry Pi, but it might not be, you might not get a lot of throughput. It's just like, this is purely an Intel Celeron like capability, and then it's running on a 2-core 4 GB RAM. So
and it's just to add a little bit more color to that. From a processing perspective, the Pi is plenty capable of running ARM. The issue with the Raspberry Pi is the limited I/O. The way its Ethernet is connected is USB interconnected to the chip, so it's can't even run full gigabit reliably. Those kind of things. But in later versions of the Pi, that's likely to be overcome, and there are certainly Pi-like dev boxes with much more capable I/O that could be options as well with the ARM. I have another question that's just come in on the chat, and given it's 8:59 California time, I'll make this our last, which is from Abbott, and it's to you, Nitz. Does AWS Outpost provide 5G radios for rental as a service?
So currently, like in reInvent of this year, we did a public preview of a private 5G network as a solution, right? Like, so I think that's probably what it is alluding to. So there is a private 5G service that was offered where your customers can order, like a full deployment with the SIM cards and everything, and all they have to do is plug and play. It's like based on the throughput. How much throughput you desire, we will ship that many number of devices, but that's still in preview. And the Outpost with 5G radio, it's coming, and Outpost runs Magma at this point. Like whether that 5G solution will it include Magma and all of that, it's still being worked on. But the preview currently, does not provide Outpost yet. It's fully running in the region, and we are only sending the RAN provider, right? So it's not Open RAN yet. From what I understand, I thought it was one of those telco providers 5G stack, but I think it is we always go where our customers take us, and in this case, as we start seeing more interest for Open RAN and like different core options from the customers, we will start moving there. The primary intent behind the, like the 5G solution was for customers who are not fully familiar with deploying a private network and people who just wanted a turnkey solution. We just started with something that we could readily take it and ship it. But as you can imagine, we will continue to optimize and scale and start giving more options to the customers.
Thanks, Nitz. And I also want to extend thanks to everyone who took a valuable hour of their day today and joined us for this call. Hope it was helpful. Special thanks to Suresh Parthodon, the development team, Maciej and Nitz for coming and speaking to us today. And with that, I think we're at time and we can wrap this month's session. So once again, thanks to everyone for joining us.
Thank you, Phil, for your support as well.
Thank you, Phil. Thanks, everyone.
Thank you.
Thank you.
Thank you.
Thank you, Nets. Thank you, Mercy.